Critical angle is the angle of incidence in the denser medium corresponding to which the angle of refraction in the rare medium is 90 degree. That we have discussed already when we have done the critical angle, and refractive index that we have already discussed, that is it is the ratio of sine of the angle of incidence to the sine of angle of refraction. So now we are going to discuss in today's video that what is the relation between the refractive index and the critical angle. So my name is Suram and I welcome you all to my YouTube channel. So let's start the today's topic, relation between the refractive index and critical angle. So suppose we are having the two media like this. Here we discuss, this is the water here in the tub, suppose, and this medium is the medium B and this medium is the medium A. Means A is the medium which is rare and B is the medium which is denser. Now we are going to discuss when the ray of light is traveling from denser medium to rare medium. Like suppose ray is traveling from here, from denser medium, this is the denser medium, and at the point of incidence this will be the normal line, and this angle will be the angle C. This is called the critical angle. This is called the critical angle. So here the ray of light will not refract outside, but it will passes along the surface of water by making an angle that is 90 degree here. Means angle of refraction R will be here 90 degree. Because critical angle that we have discussed already, critical angle is the angle of incidence in the denser medium corresponding to which the angle of refraction in the rare medium is 90 degree. So that we are already knowing. So if we talk about the refractive index of medium A with respect to the medium B, refractive index of medium A with respect to medium B, then it will be sine I over sine R. That is the definition of refractive index. So if we talk about the sine I here, that is sine C. Angle of incidence is C, that is the critical angle, and sine RA here is 90, sine 90 degree. That is the refractive index of medium A with respect to medium B, and this will be equal to the refractive index of medium. If we talk about the refractive index of medium B with respect to medium A, then this will be the reciprocal, that is sine 90 over sine C. Is it sine 90 over sine C? And if we talk about sine 90, what is the value of sine 90 degree? That is equal to 1. Is it? So sine 90, as we are knowing, it is 1. That is 1 over sine C. So it means refractive index is equal to 1 over sine C. This is the relation between refractive index and the critical angle. So we can say refractive index is equal to cosecant, because 1 over sine is cosecant. So 1 over cosecant C. Either we can write like this, or either we can write like this. Refractive index is the reciprocal sine of critical angle, and refractive index is equal to cosecant of critical angle. So this is how the refractive index and the critical angle are related to each other. So critical angle for the glass that you have to remember, that is 42 degree. Critical angle for glass is 42 degree, is it? And critical angle for water that we have discussed already, it is 48 for water, is it? For water. And for diamond it is 24, is it? That is 24 degree. These are the value of critical angles for the different media. So now next topic So this relation, sometimes it can be asked that what is the relation between refractive index and the critical angle. So you can do in this way, that refractive index is equal to 1 over sine c, it is, or we can say refractive index is equal to cosecant of critical angle. Next is the applications of total internal reflection, applications of TIR. So what are the applications of TIR? Very first is, why does the upper surface of the water contained in the beaker seems to be silvery sometimes if it is held above the eye level? So why it happens? So this happens because, suppose this is the water taken in the glass. Here in this there is the water. This is the level of water, suppose, and the ray of light which is traveling from rare medium, it is entering from air. So it will show the refraction here. It will bend like this. It will bend here at this surface, and critical angle for water that we are knowing, it is 48 degree, is it? So at certain angle, if it is falling here, then it get reflected back. It will not refract, but it will get reflect back into the water, is it? So here it is getting reflected towards the eye. If we are seeing it from downside, if we see it from downside, means from downside we are seeing to the top surface, then here the TIR take place at this surface, is it? At this surface there is TIR. So TIR is going to take place at this surface. So that's why the upper surface of this water seems to be silvery. This is the reason, is it? So second example or second application is, that is why a test tube placed in the water, when it is held obliquely, or if we see it obliquely, and it appears that upper surface of this test tube is silvery, is it? Just like this. If you see, if you place a test tube in a beaker, suppose this is the beaker which is containing water, and if you place one test tube here like this, this is then test tube, and it is containing water here inside the water, and if you see from here, from top, then rays of light which are entering from this surface at normal angle, they will pass without any deviation, because they are passing normally, and in this surface it gets reflected. It will not refract inside, but it will get reflected, right? Because the angle of incidence will be greater than the critical angle. So here at this surface again TIR take place, is it? So because of the TIR, that is total internal reflection, again the whole rays are reflecting towards our eyes. So at this surface it seems to be silvery. This is the reason of silvering surface of this test tube. Then third application that we have, it is, why do the diamond sparkles? Why do the diamond sparkles? That is again because of the same reason. The cutting of diamond is done in such a way, is it? It is because of the cutting of diamond is done in such a way that the ray which is entering inside it gets suffered from the multiple reflection, is it? It gets suffered from the multiple reflection inside, like this. It gets suffered from the multiple reflection inside, is it? The ray which is entering inside, it gets suffered from the multiple reflection due to the cutting. The cutting of this ion is done in such a way that it is suffering the maximum reflection inside. So when the ray is coming out, it has to suffer the maximum reflection because of the cutting of the diamond, and it means the more time the light will remain inside, so that is the reason of sparkling of diamond, right? That is the reason of sparkling of diamond. So these are the applications of TIR. Then we have the fourth case, that is a total reflecting prism. Fourth case, we have totally reflecting prism. Totally reflecting prisms. So we are having three types of prisms actually in this case. That is, three kinds of deviation take place in the total reflection prism. Deviation through, first A part is deviation through 90, deviation through 90 degree. So very first we are going to discuss, that is the deviation through 90 degree. How will this deviation take place? So for this we will discuss, we'll take the prism, it is a 90 45 45 prism. This is the angle 90, this is 45, and this is also 45. Suppose these are the surface AB, BC and AC. These are the refracting surfaces. So when the ray of light is, suppose there is an object PQ, the ray of light is traveling from this object and falls normally on this surface. Normally means at 90 degree. So if it is falling at 90 degree on at the surface AB, so it will pass without any deviation, because when the ray of light is traveling at entering at 90 degree, so it will pass without any deviation. So at this we have to find out that what is the angle of incidence at this surface, at surface AC. So this is the normal line here, and this is also the normal line at the point of incidence. So now we have to find this angle of incidence. What is the angle of incidence in this case? So angle of incidence will be what? As we are knowing, this angle is 45 and this angle is 90. So what will be this angle? This angle will also be 45, is it? So if this angle is 45, then this is 90, so this angle will also be 45, is it? Same in this triangle also. If you see this triangle, this angle is again 45, this angle is 90, is it? So it means this angle, remaining angle, is also 45, is it? Because this total is 90, is it? This total is 90 here. So if this one is 45, this remaining will be 45. So at this surface AC, if we talk about the AC surface, AC 45 is the angle of incidence. So 45 angle is greater than 42 angle, is it? Because critical angle for glass is C for glass. C for glass, how much it is? 42, is it? So 45 is greater than critical angle, so it means there will be TIR at this surface. So here at AC there will take place TIR. So it means the ray of light from this surface AC will get deviated downward like this, and this surface is here also like downward, and at this surface again will fall at 90, because this is again 45, is it? And this will be 90, this will also be 90. So it is falling at 90, so it will pass without any deviation. So here the image of this object will form, that is P dash and Q dash, is it? So this is how the ray of light has deviated through 90 degree, because here if we see here, then this total deviation is 90, is it? This total deviation is 90 at this surface AC. So this is how the total refracting prisms are used to refract the ray of light. So this type of reflection, you might have seen it is used in periscope, is it? And why it is used with prisms, are why it is better to use, because these are not absorbing the ray of light, so maximum reflection will take place and the image formed will be much clearer as compared to the mirror, is it? So that's why these reflecting prisms are used into the instruments like periscopes. Then we have the second type of reflection or second type of deviation, that is the deviation through 180. Deviation through 180 degree. How the deviation through 180 take place? So that you can follow this. If the ray of light is falling like this, this is again a prism ABC, and the ray of light is entering at this surface here, again at 90, falling at this surface at 90 degree. So it will pass without any deviation. So it will go like this. So at this surface, here you can see this angle is 45. This is again 45. So if this is 45, this will also be 45, and this will be 90. This is 90, and this will also be 45. Okay. So at this surface, this is 90. Angle of incidence will also be 45, and angle of incidence will be 45 here also. So it means here will take place TIR at this surface AB. So it will get reflected towards the lower surface like this. Again at this surface, it is falling. This angle is already 90, is it? And this angle is 45 as we know. So this is the normal line. So this is again 45, and this is again 45, is it? Because this total angle is 90, so this is 45, and this is also 45. So at this surface also it will take TIR again, is it? So this ray will get reflected towards this surface again, is it? So we are knowing this surface is 45 and this angle is again 45, so this angle will be 90, and this is also 90. So at 90 it will again pass without any deviation. It will pass straight, is it? So here the image of the object will form. If it is inverted, then upright image will form, and if its object is upright, then inverted image will form, is it? So this is how here the ray of light has deviated by 180. Entering from here, it is going like this, entering from here and coming back on the same line, is it? So its total angle is 180 degrees, is it? So this is how the deviation of light take place at 180 degrees. Then we have the erecting prism or non-deviation prism. Erecting prism is what? This is again a 90, 45, 45 prism. Here you can see this is the again 45, and this one is again 45, and this one is 90. So when the ray of light, suppose here is the object, so when the ray of light is not falling at 90 on this surface, and this surface is A, B, C, at this surface AB, the ray of light is falling not at 90 degree. So it means here what will take place? A refraction. So it will bend towards the normal. Ray to the answer towards the normal. So here this angle, this is 45, and this will be, this angle will be what? This is 45 and this will be 90 total, and here angle of incidence will be 45. Is it? So it is again greater than 42. So there will be DIR in this surface. So it will get reflect like this towards the second surface, and here again angle of incidence is less than critical angle. So here DIR will not take place, it will take place a refraction like this. So it will refracted, emerge out, and here inverted image will form. So here it is upright, that is PQ. So PQ dash P dash Q dash will be the inverted image. This is upright image and this will be the inverted image. So then we have the differences between the reflection and the total non-reflection. So these are the simple points that we all know how to differentiate. Then we discuss about the next topic in the next video, that is the refraction through a prism.